Hello, and welcome to this Bell Labs 100 Year Centennial event. I was the photographer at the Centennial event, and just going to go over a couple of the highlight sizzle reels here. And some highlights. The Bell Labs celebrates its 100 years of pioneering innovations, shaping the past, present, and future. Bell Labs has laid the groundwork for the digital age and paved the path to the internet, and it continues to chart new paths and foundational technologies to address humanity's most pressing challenges. Bell Labs is located in 17 locations in 11 countries around the world, and this took place in Murray Hill, New Jersey. In 1947, the first transistor was invented by John Bardeen, William Shockley, and Walter Brattain, and they won the 1956 Nobel Prize for the invention of the transistor. Arthur Shallow and Charles Townsend invented the laser in 1958, for which they also get the Nobel Prize. 1964, Arnold Penzias and Robert Wilson, they are studying the cosmic wave microwave background radiation as seen as proof of the Big Bang. And Claude Shannon in 1948 publishes a mathematical theory of communication, which develops the fundamentals of information theory, which spawns the digital age. In the 1960s and 1970s, Dennis Ritchie, the inventor of C, and Ken Thompson developed Unix, the world's most important operating system, which paved the way to the internet. Willard Boyle and George Smith here in 2009 won the Nobel Prize in Physics for their invention of the charge couple device, the basis of digital photography.
Because software is simply everything. In every single device, in every single system, you can in your industry, in your personal lives, you will see software. Shari, I have bad news for you. There is also no iPhone without software. Because it's everywhere. We actually don't perceive it anymore. It's seamlessly just running and magically makes things happen. But how did everything start? Actually, it started pretty much, everything started here about 60 years ago in Bell Labs. And I would like to bring you on a journey about how things started back in the 60s and before about 60 years ago. How we define today the future and live in the future, and how we envision to disrupt the future. And what if I told you that everything started simply with one guy who wanted to play a game, a space travel game. He just wanted to have fun. Of course, this guy was a Bell Labs researcher, and just a little bit of a secret, we all are still like kids who like to play games, and that's why we are in research. And I hope some of the demos have shown you that we are really having a lot of fun here while we are problem solving really some severe and challenging problems. So this guy was Ken Thompson and his colleague Dennis Ritchie. I will let you guess which left side of Peter's fingers these two people were there, but he mentioned at the gate that he's already out, that they were basically the inventors of the operating system called Unix, just because of the desire of playing a game. They were curious about space, like curious as well. And this desire to play a game changed the world we live in. We work, we interact, and we entertain today. But what made Unix so special that it became basically all-encompassing and being everywhere? Three very simple design principles, three key features: simplicity, modularity, and portability. What do they mean? By design, this operating system, this software system, was simple. It wasn't complex, it wasn't hard to manage. Every single utility was only executing one single function, which made things very simple to understand. The modularity allowed for flexibility in the design. It wasn't this bulky implementation of software, but it really allowed for more dimensions of flexibility through its modular design. The portability actually was quite pioneering, because it helped that software was not only custom-made for one specific hardware, and it was running now through all the hardware and possible hardware. It became hardware agnostic. That's why we can have today software systems running on every single these devices, including iPhone. You will have to go through this right? This was basically the Unix principles, the key principles. And we built on this. But let's first reflect on what does software systems research mean, which is our lab focusing on. Everything and more. All the above and more. It's a salad of buzzwords, basically. It spans such a broad range of areas and topics and technical problems that makes it probably also be everywhere by design. In this jungle of buzzwords, we do have actually a very clear path defined for us. What we want to do is still having fun, but we also want to honor the Unix philosophy and be very disruptive in our research. In order to do so, we expand these three principles of Unix and say simplicity should not be only for software engineers or developers. It should go all the way down to the end user, the consumer, us here in the room. We should feel that software systems are easy to use. The modularity, we're expanding towards saying software should be composable. You can imagine it as Lego building blocks that you can stitch together to any design that you anticipate. The portability, this hardware agnostic feature, we want to generalize and say the software should be versatile and applicable to actually any use case, any vertical, to anything. We are adding two more dimensions to this, which is scalability and trust. Software should be really, our software solutions should be scalable on the one dimension at global scale or up to the space, even like very extensible in that sense, but they should be also extensible all the way down to zero, the other direction, which not everyone thinks about. Zero meaning batteryless, for example, no battery consumption, so based solutions. Minimize compute consumption. All these energy problems we want to tackle because energy consumption is today's problem. Trust, on the other hand, is all of you might have heard, oh, AI and all these features, we are uploading them somewhere. How can we trust these giants? Here he didn't mention any, but he did. So how can we upload to these companies and trust them, right? And this is not only for you, it's also in the ecosystem, in the tech ecosystem. How does one company trust to the other one? When we provide data from one to the other one, how can we assure trust? So all these problems we're tackling, and those are future problems for a lot of people. What we say, what people envision as a future problem, we have today already solutions for. Let's see what those are. So scalability. Everyone wants to use AI, everyone wants to have access actually to the resources to be able to utilize AI. And in some developing nations or in academia, maybe resources or funds might be limited, that compute simply is not available to run AI workloads. What we say is, let us democratize this and let us make sure every compute can be utilized by everyone. We call it AI by everyone, for everyone. We have a solution for this. If you run through the demo rounds, you may have seen that. But what everyone also claims is, in the future, you don't need to learn any coding skills. Are any kids here in the audience? Won't say that. I think you should still learn it. However, don't waste your time, is what some prominent figures say. Today, we have a solution, a platform that allows children to interact and learn AI and develop AI-based solutions with no coding. And you can test it out. This little cute robot is actually in the lobby. We call it Bella. Today, everyone also says in the future data centers will be a huge problem. All this traffic growth with AI, how can we cope with this and deal with that? Today, we already have a solution together with Charles Weitzer's and Ingrid's team that we say, we do know networks and data center networks. With that awareness, how can we make more efficient decisions and fuse basically the data centers, the networks with AI, with compute together and make more intelligent agentic decisions? Everyone also says, in the future, everybody will live with their AI agents. Today, we have multiple agentic solutions, agents that we interact with. I have several team members that say, I can't even imagine a single day without my agent. And it's homegrown, self-made agents that we have tailored for specific fields, like we have a meeting agent that summarizes everything and sends kind reminders by email autonomously. Everyone also says in the future, there's this huge trust problem. How are we going to solve this? Today, we have third-party verifiable, certified solutions that guarantee trust between any party in the ecosystem. So while people envision problems in the future, I think what makes Bell Labs unique is we foresee them much earlier and develop solutions for them and have already proven demos for it and actually spin-outs. So some of you, again, might have went through the demo tours. These are really the ones that we're showing in this Centennial celebration today here, but we have, of course, much more. Do we stop here? Of course not. We're curious and we want to have fun. So whatever was defined as a follow-up of the Unix philosophy, we want to push even further. I have bad news for you, Sharia. We want to touch hardware. So we want to actually really have autogenous solutions that allow us to abstract hardware more and more to make it easier to design, but also faster for innovation, and have a software layer being on top of the hardware. We also want to have tailored, custom-made, ad hoc solutions for every individual, every human being, every system, every service, in a very intelligent and autonomous manner. What we also want and envision is that our systems are self-learning and have the ability to act almost like an organic living being and make decisions to grow or shrink and solve their own problems themselves. So full autonomy in that sense.